Hello, my name is Drennan Kessinger, and I'm going to talk about databases. So before we begin, just a brief definition. A database is a collection of information that is organized so that it can easily be accessed, managed, and updated. In one view, databases can be classified according to types of content: bibliographic, full text, numeric, and images. So just a brief history. Computerized databases came about in the 1960s. They became more and more prevalent because companies began using computers when computers became more and more cost effective to businesses and more useful. The two most popular models at the beginning of databases was the codicil model and the IMS hierarchical model. So how do we classify a database? Well, there's three ways to classify a database. The contents, so whether the information stored is bibliographic, document text, statistical, or you can classify it by looking at the application area, such as banking, accounting, or if it's being used by a manufacturing company. And then the third way is through technical aspects, like the structure of the interface type. So how can these structures be organized? Well, there's 5 ways. The first one being schemes. Then we have tables, queries, reports, or views. So how do we manage the database? Because the database itself is just a program that holds the information. How we manage it is used through database management systems. And these are software programs designed to do 2 things: capture the data and then to analyze the data. And the reason behind these is because we want to maximize the value of the data. And without management systems, we're not able to do that. So what are just some types? Well, the 2 basic types are enterprise database management systems or a personal database management system. So enterprise systems are used by large corporations and governments. And these are used by governments and corporations because they have a large scalability. Personal database management systems have low scalability, and they're used for personal projects or for learning tools, such as teaching yourself more about how databases work. Now we'll talk about relational database management. This is one of the most popular database management styles used today. It was invented by E.F. Codd in the 1970s. And the reason it's so popular is because it's easier to understand and it's very easy to use. The organization of the database is in tables that are made up of columns and rows. So databases that people use every day. If you use a TV show or movie streaming sites such as Netflix or Hulu, you're using a database. It's simply just a database of TV shows and movies. If you use a weather app, computer, it's a database of weather information. Online banking is simply a database of your personal finances. And personal cloud storage is a database of music or pictures, stuff like that. So how are databases used in business? Well, they can be used for a variety of different reasons. Some very popular ones are personnel management, of all your employees' names, date of birth, where they're from, what their salary or hourly wages, any accomplishments they may have, any negative feedback you may have about them. Then also customer management. This is useful for filling orders that customers tend to order a lot. You can set it up to automatically reorder a certain product every month or however often the customer wants it. Inventory tracking is useful to keep track of all your assets. And then just simply analysis of data for marketing research or pricing research. So what are the most popular database systems used today? We will talk about Oracle later and why it's so popular, but Oracle is very popular. MySQL is also another very popular database system. And then Microsoft MySQL, which is just Microsoft's version. So Oracle, why is Oracle so popular? Well, one, it's easy to integrate and set up compared to all the other ones. It's the easiest, which is why a lot of companies like it because of its ease of integration. It has a large scalability and quick analytics, so it's able to analyze the information quickly, and it's also able to handle large projects. Scalability just refers to how big of a project can this database take on and how much information can it store and can it be modified. And then also Oracle has simplified access, which allows the IT and support staff to have easier access into the database and fix any issues that there may be with the database itself. So what are some advantages to databases? Well, the first one is it reduces data redundancy, meaning when you enter data once, you're done. You don't have to enter it anymore. You enter certain data points about the information, and once it's in the system, you no longer have to worry about it. Improve data security. With a database, you can spend as much money or as little money as you want on data security, which will keep all of your information safe. And then also just reduce data entry costs. Like I talked about, you don't have to enter data more than once. And then also storage costs. Once you buy the database, you no longer have to worry about storing your information. However, we've talked about a lot of the upsides to databases, but what are some downsides? First of all, databases are very expensive to purchase one time. It's a large cost, which can deter a lot of small businesses or just regular people from investing in them. They also do require upkeep, which leads into our next point that they need a trained personnel staff on site to handle any problems you may have. So you also have to train your employees how to use the database itself and how to operate it efficiently and effectively. Finally, if you're looking for a database, what should you be looking for? And every database should meet the ACID criteria for it to be considered quote unquote good. Atomicity is the first requirement, and this requires that all transactions are all or nothing, meaning that either the transaction goes through or it does not, meaning you don't get any partial transactions. That means information inside the database isn't changed in one spot but left the same in another. Consistency, this ensures that any transaction will bring a database from one state to another, meaning that once it's changed, it's changed. And then isolation requires that the transaction only affects the required parts, meaning if you are changing the data in one part of the database, it's not going to alter another part of the database. And finally, durability. This just means that any transaction is finalized, and in the event of database, if there's an error or an issue and it needs to be fixed, that means that the data that you have stored will not be altered. That is the end of my presentation. Thank you for listening, and I encourage you to do a little bit more research on the topic. Here are